Hey everybody, it's Mark Baggett again. Thanks for coming back for this special section on SEC 673 and Python's Pickle. I'm not going to go through my whole bio and background again. I did that in the first session. If you want to know, if you don't know who I am, you want to get some more information on who I am, you can go back and watch that 573 session that we did this morning. I'm going to jump right into talking about 673 and the pickle problem. Now, this is going to be a fun little interactive session because, well, I've got a web page that's set up with a vulnerability in it that you'll be able to work through as I'm showing you this information. You'll be able to work through and do this as well. Now, we're going to be talking about a vulnerability that's in Pickle. So even if you don't have a programming background, I'm going to show you what you need to know in order to exploit this. And what you'll find is this particular vulnerability, at least the first stage of it, is something that is very commonly found in information security. Capture the flag. I'll show you how to exploit those. Now, in my opinion, those capture the flag events are very introductory, very entry level, because they teach you how to exploit a very commonly found vulnerability, but they don't really go into much depth as to, well, what if the developer has done some things to mitigate the attack? This is a attack that technically I don't think can be fully mitigated, right? Even if the developer does everything right, there's still some denial of service attacks and things like that that are possible. However, there are some things that you can do as a developer in order to prevent remote code execution of certain modules and things like that. The traditional attack can be mitigated. So we talk about how to do that in 673, how to fix these kinds of problems. And in this exercise, I'll show you both how to exploit the very trivial one and how to exploit the more advanced version of these pickle vulnerabilities. Here's just a bit of an overview of the things we do talk about in 673. 673 assumes you know all of the information from 573, and we pick up right where it left off. We're going to introduce some advanced concepts like what a Python package should look like, a more advanced than just a module. What does it look like when you take lots of modules and put them together into a package? Something that you could pip install or run a setup.py that will move it into the installation of these Python programs. We'll talk about some of the problems that you run into with circular imports when you start developing these more complex programs. We'll talk about Python's object model and how to handle errors. We talk about a problem that we deal with all the time in information security, which is time zones and how do you process timestamps properly. We talk about multi-threading, we talk about multi-processing, serialization, context managers, command line automation. We talk about how to do logging properly in Python, how to write decorators, and we get into Python attacks against the Python programming language itself. And amongst those, we'll talk about the serialization errors. Okay, so let's jump straight into this vulnerability. Now, this little website I've had stood up for quite some time, and actually in a bit of promotion for this event. So we're going to look at this little CTF that I've got developed for you. It is at the URL that you see there. So you can scan that URL, or you can go to HTTP, not HTTPS, serialization.crabdance.com, port 6730. Now, I will say that this is on the free tier of Amazon. So I've had this running out there for a while now. It's a single instance of this process. So if it goes down, I'm going to leave it up for another month or so after this event. But if it goes down, it's set to restart itself I think it's every hour on the hour. It starts itself back up. So if you run into problems, come back and visit this URL again. And of course, this recording will be up there so that you can go through these processes as well. But what we're going to be looking at is a vulnerability that's actually been used recently to compromise several large language models because they use a module that depends heavily on Pickle. Let's go ahead and I'll show you a little bit of this website. First thing I'm going to show you here is I've got a pre-recorded video that's actually going to be taken from this website. It's going to give you a little bit of background on what serialization is and this first level of attack. So let's go ahead and watch this video where I'm going to show you how you can attack a very simple pickled a pickle vulnerability.
This website will allow you to inject a URL encoded pickled object. Now, what is a pickled object and why do you care about this? Just about every programming language out there supports this concept of what's called serialization. Serialization is where we can take a variable that's in memory and turn it into a string. And then we could store that string inside of a database, transmit it across a network, or put it in someplace outside of the computer's memory, and then load it back up again. JSON or JavaScript object notation is one example of serialization. We take a Java object and turn it into a string that represents the values that are in that object. Python, like most languages, supports serialization, but it does it through a module called Pickle. Pickle is the serialization, deserialization module that comes with Python. And Pickle has a unique function to it that makes it vulnerable to certain types of attacks. As a matter of fact, this vulnerability was used very recently to compromise some large language models. Several AI infrastructures were compromised because one of the modules that's used in AI implementations is a module called PyTorch. And PyTorch heavily relies on serialization through the Pickle module. So let's take a look at what serialization is and how it works. Okay, so here I'm going to start Python on this Linux system. Let's just create a variable x that's equal to the string test. Now, if I wanted to transfer this from this Python process to another Python process, or store it in a database, or store it on my hard drive, or something like that, then I would need some way of taking the contents of that variable and, well, storing it. How do I get it out of the computer's memory into some kind of a transferable format? Now, I'm not talking about transferring the string test. I'm actually talking about storing the variable, the contents of the variable, which in this case is an entire Python string object. What I could do is I could import pickle, and then I could call pickle.dump dump to a string, the contents of variable x. This creates this byte string that contains the object that is stored inside of variable x. Now I can take this byte string and just copy it to my clipboard. And then I could come out here to another window, say Python on Windows. Notice this is Linux. Here I am at a PowerShell prompt, so my host operating system. And I'll launch Python on Windows. Now, the way you launch Python on Windows is to use py, the Python launcher. So this finds the Python interpreter and starts it on my Windows system. Now I could import pickle, and I could pickle.load s, and then give it that byte string that I just copied from my clipboard. And you can see that that gives me back test. And I could assign that to a variable such as x or a or any other variable I want. Now that variable contains x. So in this case, I just did a very simple string. So moving it between the two hosts is, well, quite trivial. Now, what makes the Python implementation of serialization, the Pickle module, interesting is that it has this feature where after it will deserialize the data, it will run some code to go and set additional attributes on your object. And that code can be defined inside of the byte string. So that means that the person who's sending you the byte string or transmitting the byte string, or if they can get into the database where these byte strings are stored or onto the hard drive where these byte strings are stored, then they can go in and they can change these bytes. And then when you deserialize it, you'll run that code. The way that we create those objects is with a function called reduce. Let's take a look at that. I'm gonna come back over here to Linux and I'm going to say class, I'm gonna create an evil object. And I'm just gonna say this is just an object. And attached to my evil object, I'm going to create a function called reduce. Now, what the reduce function has to do is it has to return two values. It has to return the name of a function that you want to call. In this case, I'm going to tell it, I want you to call os.system. OS is a module that allows you to do things on the operating system, and system lets you run a system command. I want you to run os.system, and I want you to pass to it the ID command. Now, this second argument has to be a tuple. Normally in a tuple, you would put multiple arguments. So if I wanted to have argument 2 here and so forth, then I would put that there. But in the case of the system command running ID, actually, let's not run ID. Let's run who am I. The reason I'm going to use who am I is because who am I will run on both Linux and Windows. But that, again, that's going to be my only argument. This still has to be a tuple, so I'm going to have to just put a comma space. That's how you create a tuple that only has one argument. All right, so that lets me create my evil object. Now let's import the OS module so that that works. And let's say x is equal to an evil object. And then let's say pickle.dump x. And so there is my byte string that contains code where I'm going to execute this function. In this case, I'm choosing to select os.system, but the attacker could put the name of any function they wanted to here and the arguments that they wanted to pass to that function here, and then that would get embedded inside of this code. Now, interestingly, if you look here, you can see that it says POSIX, which is Linux, which means even though I used a command that will work on both systems, I can't take this serialized object and then move it over to my Windows system because, let's see here, copy. Because, well, Windows is not POSIX. It's not a Linux system. So if I try to pickle.load s this string, it's going to give me an error message on Windows and say, nope, no module POSIX, because it's not a Windows system. Now there are ways you could get around this. I could use a different module. I could actually call the Windows module directly. I could create my pickled object on a Windows system. You see, the easiest way to do this is to, well, create the pickled object on the same operating system that you want to run on the target system. Now, my website is running Linux, so you're going to want to serialize a Linux object. But let's just open up a new Linux prompt. This is a new Python process that's not connected to the one we just created. And in here, I'm going to import pickle. And here I'll do a pickle.load s, and I'm going to paste in that byte string that contains that reduce function, and let it unpickle this. Did you mean pickle with an LE? Yes, I did, as a matter of fact. So let's correct that. Pickle, close parentheses. And there you can see that it ran my whoami command on that system. So this byte string, which was chosen by a completely different Python process, the one in the other tab, I generated that byte string. So if I had sent this to the server, it would be running the commands that are chosen by, well, this Python process. So we can inject code into a remote system that'll allow us to run arbitrary code. Now, you're welcome to try that on this particular website. Now, the website, in addition to being able to take these bytes, I would also have to then URL encode the data in order to be able to transmit it to this particular website. So go ahead and give that a try.
All right, so let's go ahead and create a very simple exploit object, something that's going to take advantage of that pickle vulnerability. I'm going to create a new class here called a mark class, and it's just going to be an object. Now, in order to exploit these very simple pickle vulnerabilities, you only need to define one function on them, and the function must be called def dunder reduce underscore underscore reduce underscore underscore. Put self here. It only takes one argument. And then we're going to have it return back two things. The first thing it returns back is going to be os dot some function you want to call. In this case, I'm going to put os dot system. And the second thing is a list of arguments that you want to pass to that function. So I'm just going to pass to it the ID option, which is going to ask it to display the ID. Now, if I create an instance of a mark like this, and then I can import pickle, and I can do a pickle.dump s of x, you can see that it dumps that to the screen. So here I've got the byte sequence on the screen. I can't just put this onto the target website, though. I do need to first take those bytes and URL encode them. Okay, so the way that I could do that is I could import urllib.parse. And if I call urllib parse.quote, the pickle dot dump s of x. Then I'll get the URL encoded version of that. So now what I'm going to do is I'm going to take this URL encoded version of this data. Let's put that into the website and see what we get. And then over here, I'll put in that value and press enter. And we've made it to stage 2. Stage 2 says, nicely done. That would have worked elsewhere. And actually, you've done enough to compromise many large language models with just that simple exploit. But it's not quite enough here because we've done some things to try and mitigate this attack. So let's watch this next video where we look and dig into the more in-depth version of this, and then we'll come back and we'll look and see how we could exploit the more difficult version.
Congratulations. That didn't work, but it would have on, well, almost all websites that are out there that are using Python's Pickle today. In fact, what you just did is so elite, you just exploited the vulnerability that was used in compromising those large language models very recently. Now, it didn't work on this website. There are things that developers can do to control what gets deserialized. And this is something that, well, we should be teaching our developers to do. And if developers are doing that, then it's much more difficult to exploit this vulnerability. Now, I'm not completely out of the woods yet because my web page is still trusting an external source to provide me a byte stream that represents the attributes that are on my object. And so those attributes are controlled by an attacker and can be manipulated to do other unexpected things in my network. To get a better understanding of that, let's look closer at some more Python serialized objects with a more complex object. Rather than just doing a simple string, let's create a new class of object. I'm going to say class, a my list. Well, a my thing, right? And this is going to be an object. And my thing is going to have a def, an init function that takes in a self and a name. And I'm going to say self.name is equal to the name that I pass into my init function. And I'm going to say def say hi, which is going to take in self, and it's just going to return an f string that says hi, squiggly bracket self.name. All right, so now if I say x is equal to a my thing, and I give it a name like Bob, then I can say x.tab, and I can see it's got an attribute of name, and it's got an x.say hi, which says hi to the screen. So I can create this simple object. Now let's dump this and move it to another system. Let's say pickle.dumpsx. There's my object, and I'm going to take it and I'm going to move it. Let's just move it to my Windows system. So over here, I'm going to say pickle.loads, and then I'm going to paste my byte string in. Same thing we did before. And this time it says, can't get attribute my thing. You see, this Python window, it doesn't have any concept of what a my thing object is. You still have to define the classes on both the system that creates the object and the system that deserializes the object. Let's try this on Linux. So over here in my Linux window, I'm going to try the same thing. I'm going to say pickle.loads, paste that, close it, and same thing. We get this, hey, I don't know what a my thing attribute is, so I can't deserialize this. So what we have to do is both the thing that creates the serialized object and the thing that deserializes it, it has to know what kind of an object it is. Now, if I create a class my thing here, and let's just say object, and well, let's just not do anything over here. So now this Python interpreter has some concept of what a my thing is. The definition doesn't exactly match what's on the other thing, but now let's see what happens if I pickle load it it. All right, it gave me back a value. And if I say x is equal to, and I look at x, I can see that, well, dx dot tab tab, it has the name attribute, but it doesn't have the say hi method, right? Do a dir on x. Right here, I can see it's got the name attribute, but it doesn't have say hi, x.say hi, because that doesn't come from the serialized attributes that are being set. It comes from, well, the definition that's in the local Python function. X.name does contain the value Bob. So the values and the attributes are defined here, but not the methods. So if an attacker could serialize an object that was defined inside of the target system and manipulate the values that are in there, they could cause the program to behave unexpectedly. And you can see here that, well, my class definition doesn't even have to have the same attributes, or doesn't have to match exactly what's inside of that remote system. So I don't necessarily have to know exactly how it's defined in the remote system. I just kind of have to know what it's using those attributes for. And I'm going to tell you what my program is using. My program is expecting that you're going to give it an object of type custom socket. One word with a capital C and a capital S, as shown in this web page. I'm going to expect that custom socket has an attribute called .ip. That's capital I, capital P. And, well, what my program does is it deserializes the object, and then it sends a message over UDP to the IP address that's in the serialized object, to the port 6730, because, well, 673 stands SEC 673, is where I'll teach you all about how to properly create serialized objects. I'll teach you how to reduce, no pun intended, the likelihood that your Python object is going to be exploited by that reduce function. All you have to do to get the flag is to create a custom socket object that should be a UDP object with an IP.ip attribute. Serialize that, then URL encode it, send it to my website, and I will send you a message on port 673.
Okay, so what we learned in that video is that I can serialize an object and then move it to remote systems, and they don't, my definition doesn't exactly have to match, because the methods that are on the object that's defined on the remote system persist, but my attributes that I set are what get changed. So I can, well, serialize attributes. And if I can manipulate those attributes to cause the objects that are being deserialized on the remote system to behave in unusual ways, I can win as an attacker. And we have here in this web page a little bit of code that tells us that it's doing this thing. This method, and you remember the method is defined on that remote system, so I don't have to worry about creating this method. This method is going to exist. Send message exists on this thing, and it's going to send what it tells us here as a UDP socket using this custom socket object, and it's going to use self.ip to send information. So if I can create a UDP object, socket object, that is called a custom object that has a self.ip with an IP address I can control, I can serialize that because the attributes are in the serialized strings. So let's do this. Let's come back over here and let's, in this new Python window, I'm going to first import socket. So I'm going to need that. I'm going to create a new class called a custom socket. Let me make sure I spell this right. SOCKET, which is going to be a socket.socket. And let me make sure that that is the object name here, custom socket. All right, that looks like that matches. And then what I'm going to do here is I'm going to create an init function, which is going to have a self. And here I'm going to set self.ip address to be equal to an IP address of my choosing. Now over in this window, I've got a remote Amazon server. that I've already set up, and I've opened up the UDP ports to it that are required. And I'm going to just paste in that IP address of my remote Amazon server. And then I'm going to add this other method here called def dunder get state. There's also a set state, and we talk about what these are in 673. But the short version of that is that when you're using custom attributes and custom objects and custom methods on objects, you run into some timing issues with how they're serialized and what's called when it's serialized. And adding this method, just as you see it here, get state, where we're going to return the vars of self. Adding that method to this object, it solves a whole lot of problems for you. Okay, so now if I create a custom socket object, and let's try and serialize it, import pickle, and a pickle dot dump sx. All right, so now we got this byte string here. Now I still need to URL encode it, so let's import urllib parse, and let's call urllib.parse.quote on that object. And then now we've got this object here. Let's copy that. Okay, so I'm now going to need to start up my SSH server, and let's netcat listen nv listen verbosely, or don't resolve host names, be verbose. And let's listen on UDP port 6730, which is where it says it's sending it. That's the port number. If we look back over here, that is the port number that it's transmitting this on. And hopefully we've overridden the IP address, so it'll send it to us. So we're going to set up this netcat listener listening on that port. Then I'm going to come back over here to this website, and let's go back. And then I'm going to here replace that program that was running that system command with something that's going to hopefully deserialize a custom object and then send it over there. Now, okay, let me see if I can get both of these on the screen at the same time. Let's do that. And then this here. Okay, we'll bring that. We'll make that a little bigger. There we go. And now with our new object, let's submit it. And notice here, we got back our flags. Okay, so we got back our flag from the remote system. So even if they have successfully fixed the remote code execution vulnerability inside of an object, or inside of a Pickle application, which most people aren't doing. Again, this was used to compromise several large language models. But if developers did that, they even still wouldn't be out of the woods, because you can still use this to manipulate attributes and things like this. All of this is discussed in some detail, as well as what's going on with the serialization, what that get state, set state, and all of those, how to actually use pickled objects properly. We break all this down for you in 673. But let me pull back up that code just to show you what we did here. Was we created a custom socket. We then set an attribute on it that picked the IP address where it was going to send. Then when that server ran its program that it was intended to write, it was intending to take in this custom socket object and then call the methods that were on it. But because we could now influence the attributes that are on the object, it's no longer sending those messages to the server that it was originally intended to. It's now sending them to us. Okay. All right, so that's pickled objects. I hope you enjoyed this. This little CTF, I'm going to leave this up for a little bit longer. So you'll have through the end of this month or so to play with this. If it's being overwhelmed right now, this video will be posted and you can go back and watch this. When I see the traffic has died down, then I will drop it off. All right, well, I hope you've enjoyed this session. I hope you found it informative. Python is such a powerful language, and there is so many wonderful things we can do with it. But with great power, all right, I won't say it, but it is also it can be a dangerous language. So it's important to know how to use it properly. If you're interested in this and multi-threading, how to do logging, unit testing, and many other advanced concepts, come check out 673. Thanks.